Good evening. Welcome to another episode of Yummy Data Science. In this episode, I'm going to be working down my public health data science in R course at UMass in the Department of Biostatistics and Epidemiology. If you recall, in the last few videos, I gave you a historical perspective on data visualization and analysis and data science in public health. And we talked about three examples. The first being James Lind, who's considered the father of clinical trials, and his discovery of an effective cure for scurvy. And then the second person we talked about was John Snow, and who's considered the father of modern day field epidemiology. And he discovered by careful collection and analysis and visualization of data, he proved that cholera was not transmitted by the prevailing theory of those times, the miasma theory, the foul air theory, but was in fact transmitted by water. And then by tracing all cholera-related death in an outbreak in London, to a water pump, he was able to convince the authorities that be to remove the handle, which then stopped the epidemic. The third influential person we talked about is mother of modern medicine, Florence Nightingale, who during the Crimean War painstakingly collected data, collaborated with a number of key people, statisticians, and other folks interested in public health, and proved that hospital mortality for a military hospital could indeed be brought down. That the lack of sanitation, lack of proper food, care, water was causing a lot of soldiers to die from non-wound or other disease-related causes. They were actually dying from causes that are related to the absence of basic hygiene, sanitation, water, ventilation, and they were dying of infections as a result of poor conditions. And so she had a famous visualization called the Rose Chart, which was created for its shock value, and it shocked the British authorities into making changes and changing the status quo. So, having seen the historical perspective, we are now going to be talking about our second module, which is the whole game of data science and R setup. And the whole game of data science, the phrase comes from this book. Let me see if I can position it correctly. It's called R for Data Science, and it's by Hadley Wickham. And he is a key person in the world of R. So he has called it the whole game of data science. And I'm going to use another word for it. I'm going to call it the data science framework. So we're going to talk about the data science framework, and we're going to relate what Hadley is presenting as the data science framework to the three key influencers in public health history that we learned about in the previous module. So very early on in R for Data Science, Hadley Wickham presents this framework for doing data science. And let's ignore everything else for now, but let's talk about the blue rectangle here, which is called understand. Understanding the data is absolutely essential and should take a large part of your work with your data. You must know your data before you are able to analyze the results or to visualize it or to persuade others to change their minds or actions based on your results. And within the blue box, he says, okay, we may need to transform the data. So as a quick example of transform, let's think about inpatient admissions. So a person went to the hospital on January 10th, and then he was discharged on January 16th. So you might want to create a length of stay from the dates of admission and discharge. And in that case, it would be January 16 minus January 10, which would be 6 days. And then generally you add a 1. So it would be length of stay would be 1. So that would be an example of data transformation when other columns are added. Then after you transform the data, you want to visualize it. And then you may want to model it. So use statistical techniques for either predictive or prescriptive purposes. So in our case of an inpatient admission, perhaps we want to predict what the length of stay would be when the person is admitted. Because hospital administrators may be looking at a capacity and they want to predict it and they want to see how many beds they have available, how many nurses to call, how much equipment to have. And so it could be a predictive model. And then as you go along a little bit higher on the value chain, it could be prescriptive. What should you do? Should you build a new hospital? Should you contract with another team of nurses? Should you be getting more ventilators? That was the big issue in COVID. And I have, so Hadley Wickham has transform, visualize, model, and then back. So it's an iterative loop. And this is critical to understand that all this is an iterative process which improves upon the last iteration. And what I added in that we, here in this blue box, you want to add visualize again. If you're doing data modeling, you want to visualize the results of the model. So there are 2 places in this iterative process where we want to visualize. In fact, I would go so far as to say that visualization is a very key step in understanding. Perhaps you want to visualize even as you get your data in this blue rectangle. So now let me step out of the rectangle and talk about what he means here with import. So import simply means you get the data from an outside source into R. And I'm not going to assume that you have heard of R or you've heard of RStudio. I'm going to get into that later. Another word for importing data is ingestion. And if we think about the 3 historical public health figures we talked about, well, they were also ingesting data. Charles Lind was creating his own clinical trial data, and he was carefully observing results. John Snow was collecting data from many sources. He was knocking door to door. He was interviewing a number of influential townspeople. He was going to a local church that had records. So he was collecting all this data and he was putting it, not in R, obviously, but he was putting it in a place. So he was also importing or ingesting it. Now, tidy. Tidy is it's a concept that is specific to R, but it's a very universal concept, which means that you want to get the data into a format that lends itself well to analysis. And as a quick example, think about, patients who have multiple admissions. So patient went to the hospital on January 10th, was discharged on January 16th. Then they went again on February 5th and were discharged. Imagine if we were to cram all that information on one row. So you would say, oh, date of admission for first inpatient stay. That would be January 10th. Date of discharge for first inpatient stay. That would be January 16th as columns. So that format doesn't lend itself to analysis. And you probably want to change it. So that's what the process of tidy data is. And if this is unclear, let's not worry about it because it's going to become very tangible. The last part in this process at the very end is the communicate. And this is perhaps the most important part, because if you are not able to do this effectively and well, then, one would ask, what is the reason for doing the rest of the work? However, if your foundation is weak, then your results that you communicate may not be valid or accurate. So the converse is also true, that if the whole part up to communication is weak, then what good does communication do? And then Hadley Wickham puts all of this in a black rectangle, and he calls it a program, which simply refers to the iterative nature of the data science framework. So as new data becomes available, it is imported, it's tidied, we understand it, which means we transform it, we visualize it, we model it, we communicate the results. And this is all done with robust code. So that's what he's indicating. I know I've mentioned R a lot of times, but the framework applies to any other programming language. And I have experience with Python, I have experience with SAS, but this whole framework, how to do data science, getting the data inside to be able to import it, ingest it, creating a pipeline from where it is the source, where it's sitting at, into your own system, into your own analytical platform. That is called a data ingestion pipeline. And then wrangling the data, transforming the data, that is called a data engineering pipeline. And then you have data science pipeline on top of that. And then you have data visualization and communication. So this framework is relevant to any programming language. Thank you for listening.